Hello everybody. What is digital twin? We are going to discuss about what is digital twin. Everyone knows what is twin. So what is digital twin? Can we create exact replica that is digital version of anything? It's not only, human being, but digital version of anything that can be created as a replica. Digitally, we can create that model. We can create, similar object. That is your digital twin. How it is important, what it is, how it is created, what are the applications in modern context. Let us understand. Hope you are all excited about this, in the age of metaverse, in the age of avatars, blockchain, everyone talks about digital twin. So let's understand what is digital twin. So as you can see, as I told you, there is a physical model, and then out of the physical model, we can create a digital object, digital replica using certain attributes, characteristics. Digital twin is virtual representation of an object or a system spanning its life cycle. So there is a system which has certain life cycle. Throughout its life cycle, the system can be represented as a digital twin. Rather, we can represent or we can create a digital model, digital system equivalent to that system as an exact replica, and that can span throughout the life cycle. It keeps updated. Digital twin keeps updated from real time data. It's not like that human being, the twin version of human being. It keeps updated from real time data and uses simulation, machine learning, ML, and reasoning to help decision making. As I told you, digital twins are used to better decision making, better control, better perform the tasks. We'll understand in industrial and other applications. So a digital twin is a virtual model. It's a virtual model. It's not actual. We create digitally, virtually for the actual model that is designed to accurately reflect a physical model. For example, a wind turbine, outfitted with various sensors related to main areas of the functionalities. In a wind turbine, we'll see a picture. The sensors that produce data about different aspects of all the physical objects, performance of the objects, such as energy output of the wind turbine, temperature, weather condition, and so on. So we can capture all those sensors, we can capture the data and create a virtual model. This data is then relayed to a processing system and applied to a digital copy. So you can see this is a physical space and this is virtual space. So everything, not only a system, but all the components of the physical space can be created in a virtual world as a virtual space. We can have data exchange, we can have information exchange, and also we can have communication between the two. And what is important in digital twin, as I mentioned, that there will be continuous updates, based on the real-time data which is being captured from the physical model or the physical system. So once informed with such data is received, the virtual model can run the simulations. Once it receives the data from all those sensors from the physical object of the system, it runs those data, it runs different simulations to understand the data, study the performance related matters, and generate the possible improvements if there is any improvement needed in order to better functionality of that system. Then that improvement command can also be generated. It can also generate valuable insights which can then be applied back to the original physical object, and this is why we are saying that improvement is also going to happen. So this is physical twin, a virtual twin. There will be consistent communication between the two, so that there keeps the physical twin keeps on modifying based on the real time data which is getting continuously. The virtual twin is getting updated, and then based on simulation and computation, it is prompting the physical twin or physical object of the system to continuously improve. So that is the biggest advantage. So you can see a physical space here, sensors, user input, and so on. So we create a model in the virtual space. We have a database where through with the help of sensors a number of other user related data we can collect in the database. So digital twin that is created in a virtual space, the purpose is for the better diagnostics, forecasting. We can generate predictive technologies to better perform, to better to achieve better performance, optimal performance, better accuracy, improved accuracy, less timing, and so on. And the better visualization, the entire system, all the components, how they are integrated together, and any of the component is not performing well, we can assess based on visualization and can apply the corrective measure. And that's very important thing. Simulations and digital twins both utilize digital models to replicate systems' various processes. I mean, there is similarity, but simulation is the part of digital twin. The difference between digital twin and simulation is largely a matter of scale. While a simulation studies one particular process, we generally simulate a particular process or a program, whereas a digital twin can still itself run any number of those useful simulations in order to study multiple processes. So in a wider perspective, digital twin combines more and more number of simulations. Digital twins are designed around two-way communication that first occurs when object sensors provide data to the system processor, and then happens again when insights created by the virtual space or the processor are fed back with the original source object. So better diagnostic, better forecasting, better visualization are the major takeaway of the digital twin, which is created for the physical version. Digital twins are able to study more issues from far more vantage points than standard simulations can, with greater potential to improve products and processes. So as you can see that the optional one-time data exchange builds the simulation from a physical counterpart in simulation, whereas in digital twin, continuous data exchange between digital twin and the physical counterpart. So the data updation and the manipulation and correction improvement is a continuous process in digital twin because it consists of more and more number of those simulations. So what are the different types of digital twins? The types depend on level of product magnification and the area of application where we actually want to apply. It's common to have different types of twins that can coexist within the system or the process. Component twins, part twins. Basic unit of digital twin is component twin. We can create a twin for the single component of a system. Part twins are roughly same thing, but components of slightly less importance. Definitely it won't be the same. Asset twins, when two or more components work together, for a particular task, it contributes as an asset to the system. So they form what is known as the asset. That asset twins help to study the interaction between the two components, what's the flow between the two components, and creating a wealth of performance data that can be processed and then turned into actionable insights or the commands. So you can see component or part twins, asset twins, system or unit twins, and process twins. Let's understand the other system or unit twins. This enable you to see how different assets come together to form an entire functioning. Like asset, combines two components. Similarly, if we combine more and more number of assets, it becomes system. It provides visibility regarding interaction of assets and may suggest performance improvement as well. Process twins, macro level of magnification. It reveals how system works together to create an entire production activity. So this is very important. I mean, at process level or process all the processes involved in the system, we can create a virtual, processes so that better monitoring and the entire production facility or activities which are taking place are being performed properly or appropriately or not. Are those systems all synchronized to operate at peak efficiency, maximum efficiency, or will delays in one system affect the others? It helps to determine the precise timing schemes that ultimately influence overall effectiveness. So these are the different types of twins. What's the, let's understand briefly what's the history of digital twin. The idea was first voiced in 1991 with the publication of Mirror Worlds by David Plattner. This idea was voiced in 1991. However, Dr. Michael Graves is credited with first applying the concept of digital twins to manufacturing industry in 2002. Eventually, NASA's John Vickers introduced a new term, digital twin, in 2010. So from 2010, actually, year 2010, this term was formally introduced by one of the NASA's project by John Vickers. So you see here 1991 Mirror Worlds, 2002 Mirrored Spaces Model, 2006 Information Mirroring Model, to 2010 Digital Twin was actually coined and introduced by the NASA's person. So this is another evolution like 2010 I've talked about. So 2016 digital twin concept consolidation, new definitions are widespread, and we are in 21 and 23 where the digital twin is playing a significant role, in the advancement of technology and the applications. What are the advantages? Better R&D can be done. It enables more effective research and design of projects. It helps companies make needed product refinements because improvement is suggested by the digital twin before starting the production. Because at process level, at asset level, at component level, the correct remedial measures could be suggested based on how well the processes are happening inside, by creating the process twin or the asset twin or a component twin. We can ascertain whether to start the production or not. Greater efficiency, it helps mirror and monitor production system. We can also create the twin for production with an eye to achieving and maintaining maximum efficiency throughout the entire manufacturing process. Product end of life, it helps manufacturers decide what to do with products that reach the end of their product life cycle and need to receive final processing through recycling or other measures, so that there is no wastage of product. We can recommend to the recycle accordingly. Marketed industries, physically large projects. There are a number of applications. Physically large projects like buildings, bridges, and other complex structures bound by strict rules of engineering. Similarly, mechanically complex projects like jet turbines, automobiles, and aircraft. Power equipment that includes both mechanism for generating the power and distributing it, transmitting it. Manufacturing projects streamline process efficiency in industrial environments with co-functioning machine systems. Large-scale products are projects in engineering systems, automobile manufacturing, aircraft production, rail car design, building construction, and manufacturing. So these are the industries and markets for the digital twins. And in 2020, the digital twin market was valued at 3.1 billion USD. And there is an estimate, some industry analysts, experts speculate, suggest it could continue to rise until at least 2026, climbing it to estimated 48.2 billion USD or even more. Improving manufacturing efficiency with the digital twin, we can improve the efficiency of manufacturing, the production, the use of end-to-end digital twin lets owner and operators reduce equipment downtime while increasing the production. So this is one more diagram where by 2030 there is one more estimate by 2030 64.79 billion USD. That much market will be there of digital twin. There are applications like power generation equipment, large engines including jet engines, locomotive engines, power generation turbines can benefit tremendously for helping to establish time frames for regularly needed maintenance. Structures and their systems, big physical structures such as large buildings, offshore drilling platforms can also be improved by creating digital twin. Manufacturing operations, healthcare services like sensor generated data can be used to track a variety of health indicators and generate the key insights. Automotive industry in auto design, both to improve vehicle performance and increase the efficiency surrounding their production as well. Urban planning is another important area where 3D and 4D spatial data in real time and also incorporate augmented reality systems into built environments. So what's the future of digital twin? Digital reinvention is occurring in asset intensive industries that is changing, very fast changing operating models in disruptive way that requires integrated physical plus digital view of assets, equipment, facilities, and processes, and therefore we need to create that. The future is therefore limitless due to the fact that increasing amounts of cognitive power are constantly being devoted to their use. Learning new skills, capabilities, which means that can continue to generate the insights needed to make products better and processes more efficient. So to create, to produce better products, to get more productivity, to get more efficient processes, digital twins are of immense importance. As you can see that the future lies in autonomous social systems, design of future society, expansions in human capability, automatic decision making, transport environment, urban spaces, and so on, where the internet of things, human beings, digital society are the important the emerging areas where the future of digital twin can be seen as most advantageous. Thank you so much. Hope this gives some idea about digital twin. In understanding what is digital twin, why it is created, what is the importance, what are the different application areas where we can use digital twin. Thank you so much. If you like this video, please comment on the video. You can like the video. You can spread with your peers and friends if you really like the video, and subscribe the channel as well. Thank you so much.